Welcome, everyone, to our very first episode of our Case Rezolver podcast. There's a tremendous amount of discussion today around AI and customer service. But one thing I find interesting is that most large companies don't really have a shortage of knowledge. They have years of knowledge, they have hundreds of thousands of support cases, they have articles, troubleshooting documentation, and the experience of people who have solved these problems before. The problem is that when a support engineer receives a new case, finding the right piece of knowledge at the right moment is still incredibly difficult. That's one of the problems we're set out to resolve with Case Rezolver. And today I have Rajiv Kumar, who is the founder, and our lead engineer, Alec, on Case Rezolver with me today. So welcome, guys.
Thank you, Clint.
Now, rather than giving you a product demonstration, I want to get underneath the technology and talk about how an enterprise AI case solution system actually works. What problem were we really trying to solve when we started building Case Rezolver?
I'll take that one, Clint. So I'll take a step back and talk about, our journey a little bit. We as a company been working on different AI initiatives, and the areas that we were looking at is, what's going to be, something that makes the biggest impact. And when we looked around internally, because we have our own products and we get a lot of support tickets, cases, we wanted to build something for our own. We were like, we get the same type of questions. Every support engineers that we have solves it slightly differently or takes, sometimes less time or more time, depending upon who the case goes to. So one thing stood out for us early on is like, if you're going to build something, let's build something for ourselves. And in our area for product management, for other products that we do support, case resolution came in to our picture. We discussed internally, and we realized that if we are having an issue like this ourselves, the larger organization like Cisco, Ericsson, and other larger companies that deal with thousands of cases in a week, if not more, it is a lot of cases to solve and the time it takes. And if we can build something that saves a fraction of the time, for these engineers, that's what we intended to do. One thing, as you said, in large companies, it's not so much that you don't have the data or documentation, it's access of finding it at the right time. I mean, that's what basically we wanted to build. Knowledge that is built over a period of time through documentation, knowledge that's there in cases, knowledge that exists, when an engineer actually solved the case and records it. That's what we wanted to solve for.
So would you say we're essentially trying to turn case history into institutional memory?
Exactly. And that, for selfish reasons, for our company, that was the intention, right? So we wanted to make sure that it doesn't really matter who had been working on our support team for how long. We wanted the collective knowledge of the organization to be available to every engineer. So yes.
So let's make this practical. I'm a support engineer. I'm looking at a case in Salesforce and I ask Case Rezolver for help. What happens behind the scenes?
Yeah, that is, there are several things that happen. The first thing would be just understanding what the case is about. Basically, you got whatever language you're using for support, reading through it, understanding. And then you get the information that you need in order for you to answer or provide recommendation for that. So you go back and you identify the type of information that this case would require for you to retrieve. So you go and look at your historical cases, you look at knowledge article, troubleshooting information that you have captured, maybe in some other case notes in Salesforce, ServiceNow, whatever the case may be. And once you have that, now you want to build a context and bring it back and say like, hey, this is what I understood, here's what I found. And you want to present it to the support engineer. Now, you don't, Alec probably going to talk a little bit more on, how you use different components. One thing I do want to highlight as a non-technical guy, that when you're looking at the cases or any solution that you want to build on AI, you don't want to necessarily overuse LLM because that's something that you do want to avoid. So there's a lot of searching that happens. Obviously, that's in your database. LLM does help you in different contexts. We're going to probably talk about that later in this podcast. Once you build the context, you do present it to the user. AI does reason over and say like, is it something useful that support engineer is going to find useful? If not, I'm going to take it out from my list of recommendations. So that's again doing the quality check on its own. When you're presenting something, you do want to make sure that it's all at one place. You're not taking the user from one screen to another. So if you're working in Salesforce, you are pretty much getting everything on Salesforce. If you have ServiceNow or whatever the tool that you use, yeah, you want to make sure that my support engineer is staying on the same screen with the cases.
That's interesting because people sometimes assume that more data just automatically means better AI. Alec, why don't we take the case and every related document we can find, send everything to the LLM and say, solve this?
Sure, so I'll answer that. I would say that, like Rajiv was saying, there tends to be an overuse of AI in the industry. So I'd say 4 plain reasons why less is more here is, first, there's an issue of noise. So 20 irrelevant old cases next to relevant ones will actually make the AI's answer worse, not better, because there's more noise for it to filter there. And with context limits, and as context grows, the AI, their instruction following tends to degrade, so it makes its response a lot less reliable. Cost is also an issue, so every page that the AI reads costs real money. So reading everything on every ticket really doesn't scale well. There's also the speed considerations, so when performing inference, more reading means slower answerers, and that just wastes rep time. And AI models can only really hold so much at once anyway. I don't believe there's any market AI, including Salesforce's, that will be able to handle the context of hundreds of thousands, maybe even millions of cases that a company has received historically.
So retrieval is almost as important as the intelligence of the model itself.
Yeah.
Is that what you're saying? Yeah.
Being able to parse down information into what is actually relevant allows the AI to more confidently give answers, because ultimately an AI is only as powerful and reliable as the infrastructure that's built around it. So there's the temptation always to use AI for everything, when in fact it's the pairing of AI between reliable infrastructure and a framework built around it and an LLM that actually creates a powerful AI.
Let's talk about something that comes up constantly in enterprise conversations about vector databases. Can you explain what the vector database is actually doing without giving us like a math lecture?
Yeah, of course. So we have two versions of the Case Rezolver. There's a hybrid version and there's a Salesforce native version. The one that we ship as default is a Salesforce native version, and that comes with something called an embedding model. So Salesforce uses, I believe it's BM5 large, and what that does is it basically looks at your case and it breaks it down into vectors, which is basically numbers. So what a vector database does is, imagine a room where contextually and semantically similar stuff is, let's say, over by the window, everything regarding, let's say, a customer not being able to fill out their billing information. That's all going to be over there in the corner by the window. Or something regarding, let's say, a technical issue, that might be over there by the table. So it kind of groups things in almost a 3D space similar to each other. So if something new happens or a new case comes in, you're able to break that down into vectors as well and ask yourself, where in the room would this be put? And that allows you to find closest neighbors in similar cases. So that's why vector databases are used. And I'd say what makes that better than something like keyword search is you might have two cases. For example, a new case might be like a customer can't complete checkout after changing their billing information. Well, let's say an old case says error after updating credit card. Those share no similar words. So a keyword search actually wouldn't turn up an old case, but the semantics are very similar. So a vector database allows you to find similar cases without the wording actually being the same. And it's actually a pairing of the two of those, a keyword search and a vector database, that creates a powerful hybrid search system. And that's what we utilize.
Okay, but the vector database isn't actually answering the cases.
No, the vector database is just a big storage. of all the past cases that we use to parse down the information into actually relevant historical cases, retrieve them, and feed that to the AI. That is called grounding, where you ground the AI in real information. Something for reliability you really don't want is the AI to do the reasoning for itself. What makes it reliable and provide consistent deterministic answers is grounding it in actual information.
So, Rajiv, there are plenty of standalone AI applications. Why did we decide that Case Resolver experience should be native to Salesforce?
Yeah, that's again important question as a product manager. In between many of us, we spend a lot of time debating that. One thing was clear that we wanted this to be in the app that a support agent is going to use. And I keep bringing in Salesforce. I also talk about ServiceNow. There are other support applications that exist. And there are a couple of ways to build that. One is going to be you build a wrapper app within Salesforce, and obviously you have everything else outside. It has its own advantages, which pretty much work in favor of larger companies. When you look at mid-sized to smaller companies that also need a case resolution system, it's a bit of a challenge for them, even if the interface remains the same, to manage the whole stack. It's not that easy for a mid-sized business, $100 million or so, building its own infrastructure where all this critical case components are being sent out and keeping it secure. So keeping that in mind, we knew that the interface is going to be Salesforce. We also know that Salesforce has a pretty amazing AI infrastructure available now. They got Data Cloud, we got Einstein, we got Agentforce. So tool-wise, building on Salesforce native wasn't a big challenge for us. So we decided to build that. As Alex said, we have a hybrid model as well, where you have a Salesforce application for larger clients. If they want to host the solution on their own servers, we would be able to do that. Regardless, the interface is going to be on Salesforce for usability reasons. So the thing I want to highlight is, again, AI should come to where employees work. Employees shouldn't have to leave their workplace to use AI, right? So that would be the premise across all AI tools that I've worked on or built. Just keep it whatever the people are using. And that's not something new. That has been used for a long time. The whole system integration concept comes from here. You don't want people to jump from one system to another. And that pretty much is true for AI as well.
So, Alec, we've mentioned retrieval, vector databases, and LLMs, but where do AI agents fit into all of this?
Sure, that's a great question. So I think it's important to first define what an agent is, because there tends to not be a great understanding of what that is. Kind of like what I was talking about earlier, that an AI is only as good as the framework built around it. Think of an agent as that pairing, where it is the framework and the LLM paired together. And it allows an AI to carry out a multi-step task. Rather than just doing one big block of reasoning, it allows it to go in steps, saying, okay, let me answer this first question. And based on the answer to that first question, let me answer the next one. And it allows like a more extended workflow where an AI can go step by step through a task as opposed to one big one. And I would say the way RAG fits into an agent as well is it allows it to have a bit of granularity in its step-by-step reasoning, pulling only information that's relevant at each step. And the LLM fits in there by performing the actual reasoning and routing of that information to the correct contexts.
I see. Can you give an example for those who are watching or listening?
So let's say a case comes in. How should I handle case 1, 2, 3, 4, 5, for example? So the case comes in, and first you need reasoning, right? You need to semantically understand what is going on. So what the LLM does at the start is, actually in this case it would be the embedding model, is it would say, hey, what is being asked of me? What is this case all about? And it uses that to go to the vector database and say, okay, what cases are similar to this one I have looked at? And after finding all of the closest neighbors, it performs RAG, which is retrieval augmented generation for the AI. And it provides all of those cases to the AI, and it says, hey, here are all the past cases. And a lot of systems will use another step where it's called re-ranking. So it has an LLM look over all of the returned ones and say, okay, of the closest neighbors, this is the one that I think is the most relevant to the scenario, and it will rank them from 1 to 5, 1 to 10, depending on how many cases you want to return. And we'll say this is the most relevant, and then the last one will be this one's the last relevant, but I still want to include it for context. So that step provides the most relevant cases to the AI. And then we perform reasoning again, which it looks at all of those historical cases and it says, okay, based on those historical cases, here's the recommended step-by-step solution based on our company's runbooks, our policies, what has worked in the past, and it uses that to provide a good solution to the agent.
So Alec, let's address the uncomfortable question. We all know LLMs hallucinate. And if I'm a big company, why would I trust AI to tell my support engineers how to resolve customer problems on its own?
So that is always the common question. And it definitely goes back to that point I said earlier. And this is the thing you really have to hammer home, that there's always the temptation to overuse AI, to use it at every step during the process, when in fact you want as much of it to be deterministic and grounded in yes or no answers or routing as possible. So as always, the AI is only as good as the infrastructure built around it. Stuff that's hard code, deterministic, will always provide the same logic, the same answer, no matter how many times you feed it the exact same thing. You don't want the AI to perform reasoning at every step, because that's by definition wouldn't be deterministic. So in our system, it would only cite actual history from the company's database. And a big part of it is it's allowed to say no match. So an issue would be, let's say it doesn't find any cases it believes to be relevant. You don't want the AI to then make up its own solution, right? So at that case, it would be allowed to say, hey, I didn't really find anything super relevant in the past, and I'm not able to provide you with those steps. That way the AI isn't actually making anything up. And for the cases it does return and the responses it does give, it's allowed to provide a confidence label. It says, hey, I'm not super confident on my answer, but here's what I came up with based on historical cases. And if it is super confident, it's allowed to say so. And that way you can take a look at the answer, and in that case, you don't necessarily have to follow it. That's where the human step comes in, the human reasoning, where you look at it and you can say, those steps don't super seem right to me. There's some useful stuff in there that I can pull from, but I think I'm going to do something a bit different. And what's great about our system is, in the case that the answer isn't as perfect as you would want it to be, the actual solution gets recorded. So if the support agent is like, hey, this solution isn't perfect, I'm going to do something slightly different, and after they submitted the case, that goes back into the vector database. So in the future, it will have a relevant solution to that actual problem. So it's that learning component that also allows it. And on the topic of hallucination as well, it all comes down to grounding, where you are providing it real-world information, real-world runbooks, actual company policy, and you're going to ground all of its answers in that, and it will never have to do actual problem solving and reasoning on its own.
With that being said, can we eliminate hallucination just entirely?
No, that's always going to be present. What you can do is, again, build a good framework for it to work within, rules that it has to follow and can never violate. You can improve its reliability, but it can never truly be eliminated. And I wouldn't exactly discount AI because of that. Because, for example, you can't expect an AI, something that is built to almost mimic human reasoning, to be not like a human. Humans make mistakes as well. So by having reasoning, by definition, there are going to be mistakes that are made. That's both the strong suit of AI and, the weakness of it, the same weakness that humans would have.
So there'd be a pretty big difference between something like AI suggested this versus, AI executed this or took this action.
Oh yeah, for sure. I'd say it definitely comes down to decision making on the framework there. You don't necessarily want every single case to be solved automatically. You would want very high confidence cases to maybe have some sort of automatic steps done. Usually not the whole thing, I would say, due to mistakes being made. Of course, you always want the human checking, but it allows that actual searching part to be done automatically and saving a lot of rep time. And it also provides consistency across an org. So instead of having two different reps, maybe taking two different sets of steps to solve the same solution, it allows for consistency there. So even a veteran support agent or a new one would both be able to pull the same information, even if the veteran knows all these past cases and is like, oh, last year I solved this same case. A new person who might not have that experience gets to draw on that experience without having to search for it. Even if, like, let's look at the alternative, right? If a new person comes in, they don't know what to search for other than the problem itself. So there might be resources out there that they never know about, they wouldn't search for. But the AI allows them to draw on all that past history, even cases they would have never thought to search up. So it provides that level of consistency.
So, Rajiv, let's talk engineering a little bit. What did we initially think would be easy that turned out to be difficult or more challenging?
Yeah, and I would broaden up the question a little bit, Clinton. Talk both product and engineering. And so, you would think building this is pretty easy. And that's how we went into this. And, every step of the way, you realize there are things that are missing or things that need to be decided on. And I'll give you examples. Let's talk on the product development side, and then we'll talk on the actual implementation side. But the challenges in product development would be picking up the right technology stack. I mean, that's where we spend a lot of time. Should we build it by its own standalone and build integrations? Should we build it just on Salesforce? Should we build it on ServiceNow or some other product platform? So that was, that's how and within that, then you have, if we do build it outside, what vector database, what agent studio, should we just have our own Python-based agents and so forth? So that took us, a lot of time in deciding, what our market is. And that's going to be the case, for anybody building the product. The piece that next to that is user experience. It's extremely hard to build the right user experience with AI. I've been in the industry for 30 years, built a lot of products, mobile, web, and of course they are difficult. I mean, a good product always has a good user interface, intuitive and helpful and so forth. With AI, at what point you interrupt the flow? What point do you provide a suggestion and how you word it so the user is not confused? So that was extremely hard, I would say, looking back. And then when you look at how you roll it out, a lot of the assumptions that you make are not true because even for ourselves, let's say, when we use this for us, the challenge that we run into and we had, even though we have a lot of cases, there's no one place that I could say, like, I got all the case information, for the last 4 years, 5 years that, we've been using Elixir support. That's our healthcare product. So for that, some of them are in SharePoint, some of them are in emails mostly, some are in Jira, some in a ticketing system that we use. So just getting all the data together was a challenge. And put this data in the place where it's accessible to our AI solution. And when you look at the data itself, the quality of data is not good. Some people took very good notes, some didn't. Some have closed the case, resolved, and the case was not resolved. So I'm sending the wrong signal to my AI engine. So the data was a big problem when we look at the implementation itself. When you look at the development, it has its own challenges. When you look at the implementation, I would say the data side would be the most complicated. Now, When you work in a larger organization, I would think the integration would be a pretty large challenge. How do you actually bring data from multiple systems into one place where you can dig into it?
So data governance and quality is a challenge, but what about the data model is that one of the easier components?
It is important. It's one component when you look at the modeling. You do have to put in a lot of thought, like in any data model, because that's the foundation for any system design. And I always spend a lot of time and I tell my team, figure out what the right amount of data and where it lives and how it's going to be connected with each other, right? It is a difficult task, but it's not the most difficult when you look at the challenges we had. It's more of the quality of data or how do you bring the data together. Modeling is difficult, but not the most challenging part of it.
All right. So a large company listening to this might say something like, hey, we already have AI engineers, we have developers, we have access to LLM ourselves. Like, why wouldn't we just build this ourselves? Rajiv, can you help clarify on that?
Yeah, no, I think again, it sounds like if I say we went back and forth, and I've said that in multiple questions that you asked me internally, because we go through a lot of debate internally at Mirketa. And one of the things that we did talk about is why wouldn't people just build it? What is to stop, a large company with a lot of smart people working, a lot of them probably have much smarter people than what I am, leading this product. So that definitely was a thought that crossed our mind and we discussed. And I tell you why we decided to build it. When you're focusing on your core business, you want systems to support you, build your capabilities, organizational capabilities around that. Building a system like this, it does require a different set of capabilities. You certainly can hire people and build that, but it's not a one-time effort. You got to figure out the entire product development side of it and the maintenance part. In this particular case, you're going to have working with Salesforce, which has its own set of challenges, right? How do you actually, build a solution that works within the Salesforce governance parameters? It's not that easy. It requires a lot of experience. I've been working in that space for probably, 15, 16 years. And one thing I've realized is that I still learn on where my application is going to fail in Salesforce. And then you talk about permissions and what type of permission, how are you going to put restrictions? You have security, you got system monitoring, you got prompt and model management that's going to be an ongoing thing. User experience, every time something changes, how are you going to be evolving this product and make it easier or better for your users? So all of those things come back. This situation is no different than what we had in the past, where people could build their Java app, people could build their .NET app, but they did go with SaaS. People can have SaaS, but within SaaS, you need to have an AI engine that works on top or along with SaaS, right? We thought that was a good enough business opportunity, and there was a good enough reasons for us to build, because what seems to be a reasonably simpler thing to build for prototype, when you go to production and roll it out and maintain it, it's a different story altogether. So that's why we ended up building it.
And if I could add something there, I'd say an important thing a company must ask themselves in the build versus buy question isn't necessarily can we build it? It's do we want to own it, the maintenance, the security, and upgrades forever in perpetuity? Or would we rather have the engineering team at another company do that? And a lot of times during development, things break, things won't work, a deployment won't be ideal. So that allows, before it ever hits your company, it to be tested, it to be ready to go, and all of it can be owned by another company, and you can trust that each deployment is going to be tested.
Right. And if I can, summarize finally, Alec, and I hope you agree with me that, building proof of concept in AI is super easy. And maybe that's what gives people an impression that I can build things easily. And we have had clients that talk to me and they say, like, they want to build things internally. They got the agentic platform. They're going to build stuff themselves. I'm yet to see, how they're going to progress. But building something, proof of concept is easy. Building something and maintaining, like you were saying, in production quality system is extremely hard. Both building and maintaining down the line, extremely hard.
I agree.
Rajiv, today we're primarily talking about AI helping someone resolve a case. Like, where else do you think this goes?
Yeah. And again, I would also pull in Alec to answer that. So there's a natural progression to the whole thing. And most of us have been noticing it, right? We're using in some form or the other. First, some intelligent way, we were able to find information. Then we were relying on the intelligence to tell us, or recommend what to do. Then it ended up preparing actions, right? So there's a progression, and where it all leads to it, can it do the work for me, and how much can it do, and can I rely on that so I have a quality or supervisory checks built on top of it? That's where I see things to go. And they don't, even though we build case resolution app, on its own, it's not going to be working by its own. It is going to be working along with other agentic solutions that the client's going to have, whether somebody is using it in a home care situation where it essentially is part of the home visit, that it helps people, manage or provide care in a better way, or it's some field service engineers that's making a visit to the field and using case resolution system to figure out, how to address a particular problem or troubleshoot a problem at home. So I see the whole thing is going to lead to AI doing more, but in a more connected way, right? So even though this product is going to go out by itself, the way we're building it, so it is integrated with other systems very easily. So I see that, the whole ecosystem of enterprise application connected together down the line. I'll pass to you, Alexi, if you have anything to add.
Yeah, I'd say the places this goes next, I would say the main four ones would be, first, what else can we do for a support rep? There are steps beyond just the resolution. There's communication with the customer. So currently what our system does is it helps to draft emails for the client, and it also generates call scripts for them to talk on the phone with the client. And whenever you're generating via an AI, there's a human touch that's kind of missing. And the wording can sometimes be stilted or awkward, and improving those templates that are generated and making them very personable and human, and really refining that so that the communication between our support rep and a customer is seamless. And the benefit is, well, the question you might be asking yourself is, why automate that at all? First of all, it provides consistency. No matter what rep you're talking to, you're going to have very similar responses. And as opposed to having it all done by a human, it allows there to be actual information in there. The AI will provide good information that you might want to provide a customer, stuff that the rep might not necessarily know on hand. I'd say another place this comes down to integration. How easy is this to deploy to a customer environment? What servers can we make use of? How can we make this as maintainable for them as we can? So we're working on some auto deployment flows that allows them to easily deploy it to their servers and make use of the data that they already have. I'd say building off of that, it comes down to the third place this is going, which is ingestion. Like Rajiv was saying earlier, there's many different places data can live, and that's not necessarily something you may want to or can easily migrate over to the vector database. So the question becomes, how do we get all that information in there, and how do we create an engine that can ingest many different types of data and transform it into a standardized format where everything in the vector database is formatted the same way in a format that AI can understand. So it comes down to building a really dynamic engine that can handle all different types of data, and that's going to come with time for us to develop. And it's something that we're definitely working on.
So in addition to the engine, from the user experience, there's a process to all of this. So you're moving from AI search to AI recommendations to then the execution by AI. Is that correct?
Yeah, I mean, that's the direction. And the more important question becomes not simply how intelligent is AI, but what authority we should give it, right? So essentially, that's the direction we go in.
And I'd say the fourth place that we take this comes down to not necessarily something new, but refinement. It would be very naive of us to build while saying, hey, we're the only solution out there on the market. So the question then becomes, how do we differentiate ourselves? And ultimately, what differentiates competitors comes down to intelligence and reliability. What is going on under the hood? It's not necessarily the stuff you'll see. UX matters a lot, and the experience between the different solution matters a lot, but the most important thing comes down to the output, the solutions it's providing you. And that comes down to us having the smartest, most reliable way to retrieve information and providing the smartest answers. So to that end, it comes down to tuning the search, providing new techniques, such as the ones we already use, and tuning them, such as the hybrid search we use, the re-ranking we use, what models we use, because all of that not only factors into the intelligence of the answer, but also the latency. We could use some massive model, but that might lead to 10-second responses. So there's trade-offs everywhere that needs to be considered when tuning. So I'd say that's the next place we take this, is really not just new features, but really getting the product as refined and intelligent as possible.
Let's finish with one prediction. Alec, if we sit here, let's say 3 years from now, and we record the same exact conversation, what's going on with support engineers? What are they doing manually today that you think it'll be really hard to believe that they were ever doing that manual?
I mean, it comes down to just search. So to think of a parallel here, what is the difference between pre-internet and post-internet? Before, to find information and to really educate yourself, you'd have to go to the library, you'd have to search through books, you'd have to know what you're looking for. And now that we have the internet, it's hard to believe that people ever got information that way. That now you can search something and now everything's at your fingertips and it's going to be relevant. And you don't even necessarily have to have in mind the sources you're looking for. It's going to show you the most relevant things. This is very much a logical iteration on that. In the same way that we hardly believe that everyone used to have to go to the library, now we're going to find it hard to believe that every single person had to search things manually and determine what's relevant, because now the AI does that reasoning step for you. So it's hard to believe, I think in the future it will be hard to believe that you ever had to search by hand, because now you can get a curated response off the bat.
And if I can jump in here, Clint,
Yeah.
to me, the way the life has changed personally for me, a couple of things. One is just writing responses, emails. So I don't think people are going to do that in future. Once you have the context, even if you are building the context manually for solution, sending a response is not going to be something that the rep should spend time. You should close the case or say like, hey, write the response and send it. AI would do a fantastic job. And a lot of things that, ask for reset or basic, certain cases that come to us in our world, let's say, and I'll just say Elixir, permission issues and, people not having access to a particular feature. Those type of cases, AI, I don't think rep need to do manually. You could actually automate that piece. So that's my prediction for 3 years.
This is what makes this space interesting to me. I mean, companies have accumulated years and years of knowledge through customer interactions, and we're not looking to just simply put a chat bot in front of that information. It's more to turn real knowledge into something that people can actively help use to solve problems and help organizations take actions. I want to thank you guys again for joining us today, and thank you everyone who's watching. This has been great.
Thank you. It's been great.
Thank you, Clint. It was great.